We're going to solve rational equations. So what you guys did on your quiz, some of you did well, some of you not so well. You have to get a common denominator. And then once you get a common denominator with your rational equations, you don't have to worry about it anymore. So what happens is once you make the entire equation equivalent, once they all have the same denominator, then just becomes a normal linear equation, which is from 1 point to a. One thing that is new is you guys are going to have to check for what's called extraneous roots or solutions. Right? The word roots and solutions both mean the same thing. What that means is you get an x equals a number, x equals 2, whatever. But when you plug 2 back in, it makes the equation untrue. And the reason it makes the equation untrue is because all of these, when we talk about rationals, those are fractions, right? What number can not be in a denominator of a fraction? It's the only number that cannot be in a denominator. 0. So an extraneous solution will make your denominator 0. So that's what we have to check for. So you'll see what I mean by that in a second. So anything highlighted, we're going to do. All right. I'm going to try to show you guys the easiest way to do this so we can make our life easier. But when I look at this, the first thing I want to do is I'm going to put a 1 underneath my whole number. Do you see how you have rationals, you have fractions, and then you have to get a common denominator? So between 3, 4, and 1, what's your common denominator? 12. I'm going to write it over here. Because once we figure out what the common denominator is and we make them all equivalent, then we don't have to worry about the bottoms of your equation anymore. So what I mean by that is I look at my first fraction. It has a 3 in the denominator. What would I have to multiply it by to make it 12? 4. So what you do to the bottom, you do where, guys? To the top. Okay, good. So look at your next fraction. It has a 4. What would you have to multiply 4 by to make it 12? 3. So what you do to the bottom, you do where? To the top. And then the last one on the other side of the equal sign. What would I have to multiply 1 by to make it a 12? 12. So what you do to the bottom, you do where? To the top. Now all of these denominators are what number? 12. 3 times 4 is 12. 4 times 3 is 12. 12 times 1 is 12. So you no longer have to worry about the denominators. They're gone. You just have your numerator to worry about. So you have 4x plus, what's 3 times 3? 9x equals, what's 12 times 2? 24. Good. And then what do we do with 4x and 9x? You combine them. 4x plus 9x is 13x equals 24. And then do what? Divide by 13. So you get x equals 24 over 13. Some of you are going to be like, wait, did I do something wrong? That's a gross number. You're going to get some gross numbers sometimes. Since you have an equation, what can you do with x equals 24 over 13 to see if your answer is right or not? You can plug it back in. Is that an easy thing to plug back in and check? No, I wouldn't worry about that. But you have to check always for extraneous solutions. The only time you guys are going to have an extraneous solution, something that doesn't work, is if there's a variable in the denominator. Are there any variables in the denominator here? No, so you don't have to worry about it. So if you have something like number 3, okay, we'll go through this one kind of quickly too. First thing I want you guys to do is write a 1 underneath here. What else do you notice? There's a minus sign. What do you think I should do with that minus sign? I'm going to just change it to a plus and then stick the minus right there. So I remember that that minus goes with that x. I'm going to have to do something with it. But guys, between 5, 2, 1, and 10, what's your common denominator? 10, okay? Again, I'm going to write it over here because once we get everything to be equivalent, we don't have to worry about that 10 anymore. So look at your first fraction. What do you have to multiply 5 by to make it 10? So if I multiply the bottom by 2, then I do the top by 2, right? What about 2? What do I have to multiply that by to make it 10? 5, good. What you do to the bottom, you do to the top. What about the 3? Multiply the bottom by 10 here, so I'm going to multiply the top. And then what about the last one? 1. It already has a 10, right? So now that they all are equivalent, we don't have to worry about them anymore. So you just rewrite the equation on the top. What's 2 times x is 2x minus 5x equals, what's 3 times 10? 30 plus 3x. Now what do? How do I solve an equation like this? Can I clean up anything on the right-hand side? No, we can't put anything together, but can I clean up anything on the left-hand side? Yes, 2x minus 5x, negative 3x equals 30 plus 3x. Now, I personally always like x's to be on the left. Some of you want to always keep them positive, whatever you want to do, but I'm going to subtract 3x from both sides. What's negative 3x and a negative 3x? Good. Negative 6x equals 30. And then what do? Divide both sides by negative 6. Perfect. And you get x equals, what kind of 5? Negative 5. Now look back. We talk about extraneous solutions. Do you have any variables in the denominator? Nope. So you don't have to worry about it. It's fine. So we're going to do the exact same thing, guys, on a couple more examples. But now we have variables in the denominator. You could get an extraneous solution here, meaning something that makes the equation untrue. Makes your denominator, what number can x not equal? 0. Because what happens if x is 0? If you put that right there, that becomes undefined, right? So if you solve this and get x equals 0, you would cross that answer out and say, oh, there's no solution. Well, let's see if that happens. Look at your denominators, guys. Between 1 and x, what's your denominator, the common denominator going to be? 1? What would you multiply x by to make it a 1?
0.
What would your common denominator be? 1x, right? Because you can multiply your denominator of 1 by x and make it an x, but you can't multiply x and make it a 1. So your common denominator is going to be an x. So look at your first fraction. What does it already have in the denominator? An x? All right, so go ahead and leave it. Look at your second fraction. What would you have to multiply the denominator by to make it x? X. What you do to the bottom, you do where? To the top. Good. Look at your third fraction. What's the denominator already? X, so just leave it. And then look at the last one. What would you have to multiply the 1 by? X. So what you do to the bottom, you do to the top. And now that they're all the same, do you have to worry about the denominators anymore? No, you just worry about the numerators. So you have 15 minus what? 4x, good, equals 6 plus 3x, good. Now you need numbers on one side and x's on the other. I'm going to move 3x to the left because I like variables on the left-hand side. And then I'm going to move the 15 to the right. So my 15s will cancel. What's negative 4x and a negative 3x? Good. Negative 7x equals, what's 6 minus 15? What kind of 9? Negative 9. And then how do I get x all by itself? Divide by negative 7. So x equals 9 over 7. What did you guys tell me at the beginning was the one number that if I got x equals, I'd have to say, oh, that one doesn't work? 0. Did you get x equals 0? No, so you're good to go. That's fine. You're only going to have an extraneous solution if when you plug in that value, your denominator becomes 0. All right, let's move along. Let's do number 5. All right, this one's a little different. Put a little star by this one. I wanted to do this example because it's different from all the other ones. What do you notice about this one? There's one fraction on the left-hand side, and there's one fraction on the other side, right? When you have a fraction equal to a fraction, there's no fractions being added or subtracted to each other or anything. You just have to cross multiply. So you have 2 times 10x plus 3 equals 1 times 5x plus 6. This only happens when you have a fraction equal to a fraction. So what do I do now? I distribute. So this becomes 20x plus 6 equals 5x plus 6. You guys agree? Okay. So how do I solve? I'm going to subtract 5x from both sides, and then I'm going to subtract 6 from both sides. What's 20x minus 5x? 15x equals what? 0, okay. How do I get x by itself? Divide by 15. So what is 0 divided by 15? Just 0. Is it okay to get x equals 0? Why not? Why? Well, think about it. Extraneous means when you plug it back in, the denominator becomes 0. When I plug in 0 right here, 5 times 0 is what? 0. What's 0 plus 6? So we're okay. Look what happens up here. 10 times 0 when I plug it in. What's 3 over 6 the same as, guys? 1/2, okay? It's okay to get 0 as an answer. You just have to make sure that when you plug the value back in, it doesn't make your denominator 0. So in a case like, let's do 7. All right, let's do number 7. First of all, I'm going to say, okay, this is a whole number, so I'm going to put a 1 underneath. And I'm also going to change this subtraction to an addition, and I'm going to stick that minus sign right there so I can remember to distribute. Look at your two denominators. They are completely different, aren't they? Do you have anything that you can factor out of them? 2x plus 1. Can you make that any smaller? No. 2x minus 1. Can you make it any smaller? No. So what's your common denominator? If you were going to have to get a common denominator between those two, what would it be? Remember, we have two completely different denominators. How do we get them to be the same? You just stick them together. 2x plus 1 and 2x minus 1. And we're now going to figure out what each fraction has and what it's missing. So look at the first fraction. Your first fraction in the denominator already has a 2x plus 1. What is it missing? The 2x minus 1. So I'm going to write 2x minus 1 down here. And what you do to the bottom, guys, you do to the top. Your second fraction has the 2x minus 1. What is it missing? 2x plus 1. Good. 2x plus 1. So what you do to the bottom, again, you do to the top. And your second fraction is now the same denominator, right? So look at the last one. What is that denominator missing? Both 2x plus 1 and 2x minus 1. Now that you have them the same on the bottom, I have to do the same on the top. So 2x plus 1 and 2x minus 1. All of the denominators are the same, guys. Look, this one has both, this one has both, this one has both. Therefore, you don't have to worry about it anymore. You have just the top. I'm going to rewrite the top because this is a lot. So I have 7 times 2x minus 1 plus negative 8x times 2x plus 1 equals negative 4 times 2x plus 1, 2x minus 1. I seriously doubt you'll have one like this on your test, but just in case. So this is just a long Algebra 1 problem. What do I do with that 7 out in front? Distribute it. So 7 times 2x is 14x. 7 times negative 1 is minus 7, right? What do I do with negative 8x? Distribute it. So I have minus 16 x squared minus 8x equals negative 4 times. If you were going to multiply 2x plus 1, 2x minus 1, what's it going to give you? 2x times 2x. 4x squared. What's going to happen to your middle terms? I'll have 2x, a positive 2x, and a negative 2x. What's going to happen? They cancel, and then negative 1 times positive 1 is just minus 1. So can you combine anything on the left-hand side? I have negative 16x squared. What's 14x minus 8x? Plus 6x minus 7 equals negative 16x squared plus 4. Where do we go from here, guys? Before we solve by factoring. Okay, you can take out, well, is it set equal to 0 yet?
Oh, no.
So what do we need to do? Get everything on the other side, right? So let's go ahead and add 16x squared. What happens when you add 16x squared? The x squareds cancel, don't they? So now you're left with just a normal linear equation. Put x's on one side and numbers on the other. So I'm going to write it over here. I'm going to leave 6x on this side. How do I move 7 to the other side? I'm going to add 7. What's 4 plus 7? What is 4 plus 7? 11, good. And then I'm going to do what? Divide both, good. Divide both sides by 6. So x equals 11 over 6. Guys, I'm not asking you to plug that back in and check, but if you took 11 over 6 and put it in the denominator, would 2 times 11 over 6 plus 1 give you 0? No. Would 2 times 11 over 6 minus 1 give you 0? No. So that's a fine answer. It's just gross. That's a hard problem, I know. But the only algebra 2 part of it is getting your common denominator here. Everything else is algebra 1 stuff that we're slowly recalling, right? Kind of. All right, let's go over number 8. A couple things we need to look at. First of all, I see a minus sign here, so I'm going to change it to a plus and stick that minus right there with my 6x. What else do you notice about the denominators? I have x minus 2. I have x plus 2 here. Can I factor anything in x squared minus 4? What does x squared minus 4 break down into? X plus 2 and x minus 2. We always want to factor first. Now let's think about this for a second. Are there numbers that if you said x equals this, when you plug it in the denominator, it'll make your denominator 0? What can x not equal?
0.
No, x can be 0. Your denominator can't be 0. So what would x be? What would make your denominator 0?
2.
Positive 2 and negative 2. So if you solve this and you get either positive or negative 2, you know those solutions don't work. Those are extraneous. But if you now went through the process to get a common denominator, what's your common denominator between x minus 2 and x plus 2? What do they have in common? They don't have anything in common, right? One of them has one has the other one, and then you have one that has both. So what do you think your common denominator is? X plus 2 and x minus 2. Good. So look at your first fraction. It has x minus 2. What is it missing? X plus 2. So what you do to the bottom, you do to the top. Look at your second fraction. It has the x plus 2. What is it missing? The x minus 2. Good. So what you do to the bottom, you do to the top. And what about your last fraction? It has both, right? So now, guys, look. All 3 fractions have the same denominator, so we don't have to worry about it anymore. You have 1 times x plus 2 equals 3 times x minus 2 minus 6x. Just a linear equation. So on the left-hand side, I have x plus 2. On the right-hand side, I distribute that 3, so it's 3x minus 6 minus 6x. So I still have x plus 2 over here. What can I combine on the right-hand side? What's 3x minus 6x? What's 3x minus 6x? Yep, minus 3x minus 6. And then I like to move x's to the left and numbers to the right. So I'm going to go ahead and add 3x here and subtract 2. So what is 1x plus 3x? What's 1x plus 3x? 4x, good. And then what is negative 6 and a negative 2? Negative 8, good. And then divide both sides by 4. And what do you guys get? X equals negative 2. What were the 2 numbers we said we couldn't get? 2 and negative 2. We got negative 2. So this is the case where you would say, oh, wait a second. Look what happens. If I plug negative 2 in right here, what's negative 2 plus 2? 0. Your denominator can't be 0. So you would cross this off and tell me no solution. You could do the null set if you wanted to. Just do something. Cross it. Do something so I know you realize, oh, wait, I can't use this answer. That's definitely a possibility. No solutions. Two more. Then we're done. All right, let's look at number 9. What should I put underneath my 5? A 1, good. All right, look at your denominators. I have 1 and x minus 4. So what's your common denominator going to be between 1 and x minus 4? Good, x minus 4. So look at your first fraction. It already has the x minus 4. Do I need to do anything with it? No. Look at your second fraction. What do I need to multiply the bottom by so it says x minus 4? X minus 4, good. What you do to the bottom, you do where? To the top, good. And then what about the third fraction? Do I have to multiply by anything? No. So now that we have all of our denominators the same, we don't have to worry about it anymore. Let's think ahead. What number, if I get it, I have to say, oh, wait a second, that one doesn't work. What's going to make my denominator 0? 4, right? If you get positive 4, you're like, oh, wait, that doesn't work. So let's go ahead. We have 3x equals 5 times x minus 4 plus 12. What do I do with that 5? Distribute, good. So 3x equals 5x minus 20 plus 12. Can I combine anything on the right-hand side? Okay, so 5x minus what? 8. I'm going to move my x's to the left-hand side, so I'm going to subtract 5x. I get negative 2x equals negative 8. And then do what? Divide by negative 2. And you get x equals what? 4. What did we say at the beginning that we could not use? 4. So what do I do with that? I cross it off and I say no solution. Because if you put 4 right here, what's 4 minus 4? 0. And your denominator can't ever be 0. You're fine. Yeah. You don't want any value that if you plug it in for x in the denominator, that value becomes 0. So like look at number 11. All right, couple things with number 11. What do we notice with x minus 2? It's already factored. X plus 3, already factored. Can I factor x squared plus x minus 6? Yes. What can I factor that into? Factors of negative 6. That multiply to give me negative 6, but add to give me a 1. X minus 2 and x plus 3. So think about this, guys. What are the two numbers that you cannot use for x? Correct. Positive 2, because look, if you put it in the first fraction, 2 minus 2 is 0. Negative 3, because if you put it in the second fraction, negative 3 plus 3 is 0. So anything else will work except for those two numbers. So let's figure out, what is my common denominator between x minus 2 and x plus 3? What's your common denominator here?
6.
Look at your binomials. One fraction has an x minus 2, one has an x plus 3, and then one has both of them.
Oh, so it's x minus 2.
So it's going to be both. It's going to be the combination of the two. So your first fraction already has the x minus 2. What is it missing? The x plus 3. What you do to the bottom, you do to the top. Your second fraction has the x plus 3. What is it missing? X minus 2. So what you do to the bottom, you do to the top. And what about the last one? Do you have to multiply anything? No. Now that all the denominators are the same, we worry just about the numerator. So you have 1 times x plus 3 plus 3 times x minus 2 equals 4. So we distribute 1 x plus 3 plus 3x minus 6 equals 4. What can you combine on the left-hand side of the equal sign? 1x and 3x gives you what? 4x. Positive 3 and a negative 6 gives you what? Negative 3, good. Equals 4. One more step. Let's move the 3 to the other side. So I'm going to add 3. So I solve this, and I get x equals what? Sorry, 4x equals what? What's 4 plus 3, guys? 7. And then what's my last step? I'm going to divide by 4. So I worked this problem out. I got x equals 7 over 4. What were the two numbers that we said at the beginning we could not use for x? 2 and negative 3. Did I get either of those? No. So then there's your answer. That's it. What would happen, just say, I know this didn't happen, but what would happen if I got x equals 7/4 and x equals 3? Negative 3, sorry. What would I have to do with negative 3? Can I use negative 3, guys? No, so I would just cross it off. Sometimes you'll get two answers and one of them will work and one of them doesn't. That's fine. If you get one answer that's not allowed to work and that's what you get, then it's, you just cross off, say no solution. But if one of them works, that's okay. We're going to practice this more tomorrow, I promise. Tonight's homework is not this.